Today I am going to make a battery interconnect cable to connect two 12-volt batteries together in series for a 24-volt battery backup system for a house. So this cable is made out of 1/0 cable, so 1/0, so it's a thick, heavy-duty, high current cable. And then we have some nice copper lugs connection points on the ends. So the first part we have to do here is measure out our cable length. I think they're around 1 foot each without the terminals on the end. So yeah, roughly about a foot of cable is what we need. We'll half off a foot of cable here. Shaky table. So that's our part we need to cut. We'll use these undersized wire cutters to do so. Next, we need our terminal ends, a couple of those. What we need to do now is prepare the end of the cable for the terminal. What that means is we just need to cut our insulation back so that we have bare copper to go inside of our terminal for our crimp. And to do that, we'll do a similar process just to mark the cut where we're going to cut the insulation at. Something like that. They do make a tool specifically for this, but I don't have one, so we'll do it a different way. This works out fine for a short cable that I can just rotate around this cutting device. Doesn't work quite as well with a longer cable that I can't just rotate in my hand. So that's one side ready. Do the same thing for the other side. We want to be careful as we do this to only cut the insulation. We want to try to keep from cutting those individual wire strands. They are important for making sure we can transfer all the current we need to. So that part's done. So now we need to crimp our terminals in place. I use a hydraulic crimping tool that has, it creates a hexagonal crimp. And there's an upper and a lower die. And as you pump the handle, it pushes the lower die against the upper die, fixed moving die, whatever you want to call it. I like the hexagonal crimps. There are different versions. Some of them will come around, they'll put a divot in the center and accomplish the same task. I don't know, the hexagonal crimp looks cleaner to me, and it does a good job. So we want to make sure we feed all those individual strands inside the terminal end. We take our crimper, make sure we have our valve closed, close up the jaws a little bit, slip the terminal in place, and I'm doing this. Keep the wire in the terminal as we crimp. Those jaws come together. I typically will rotate 90 degrees. And do it again. Now we'll do the other side. Same thing. Make sure we get the wire strands inside the terminal. I found with the connection I'm making and the way that this wire has to be manipulated, if I set one terminal so the connection point is 90 degrees out of the other side, it makes a nice, nicely lays out the wire against the batteries. So here's a different way to hold this crimper. Use a vise. Same thing, we slip the terminal in place, make sure our valve is closed, just pump the handle. Just rotate it 90-ish and crimp it. That was a lot easier, and you don't have to fumble with the crimper, keeping the terminal, keeping the wires inside, so forth and so on. So that makes a nice crimp. These are, again, 1/0 cable and then a 5/16 stud, or 4 or 5/16 stud. So the last process here is to shrink on some heat shrink tubing, which I need to cut. Maybe. So we got some lengths of shrink tube. Take our utility knife and pretend like we're going to cut a straight line. So I do one red, one black, because the cable will be connecting two batteries in series. So when you connect the battery in series, you're connecting the negative post to the positive post of the other battery. So we will do one as red so that it gets connected to the positive post. Other one is black, gets connected to the negative post. You can visually use this as an indicator if you need to do some troubleshooting, or you just want to check voltages or know where your negative and positive are with a quick glance versus having to look at the battery for the molded in plus or minus. So I'll slip our heat shrink over. This isn't, it's not possible in all cases to do that. Sometimes you need to have the shrink tube on before you crimp the end on. So keep that in mind, but this shrink tube is large enough diameter, it'll go over the terminal. Best method I've found to give a nice consistent shrink is to use a heat gun. This is a cordless one, works with DeWalt batteries. It's not made by DeWalt, but it does the job. So we'll let that heat up for a minute. Kind of obnoxiously loud, but it works. So this heat shrink tubing has a adhesive lining to it. You can see what we want to do is we want to make sure we shrink that and let it heat for a moment until that glue melts. And then the shrink tube itself will shrink around. It'll distribute the adhesive and we'll get a nice seal against the cable insulation and seal at the terminal. And that's our completed cable, and we'll be ready to install that in our battery backup system.